Hi guys, welcome back to my channel Informatics. In this episode, we'll be learning about our neighbor in space, the moon. So I've already taken a video about this topic. I'll put the link in the description box below. Now, in this episode, we'll be learning more about this topic. So without wasting any time, let us learn more about our companion in space, the moon. So the moon is the largest and brightest object in the night sky. It gives us the bright white light in the night. And it is the only celestial body. A celestial body means an object in space. For example, stars, planets, asteroids, satellites, they're all celestial bodies. So the moon is the only celestial body whose surface features can be easily seen with our naked eye. Now, the Earth and the moon, they share a very powerful influence on each other through their gravitational force. Now, tidal forces have slowed the moon's rotation so that it can spin once on its axis in the same time it takes to complete its revolution to orbit the Earth. So it rotates and it completes its rotation in the same time it completes its revolution. So we can say that the moon's rotation and revolution period is the same, that is 27.32 days. Now, the moon is a barren ball of rock that lacks gravitational force to hold on to a substantial atmosphere. Now, exposed alternately to the force of the sun and the emptiness of space, our moon experiences wild temperatures. For example, the temperature at noon in the moon is 120 degrees Celsius, and when it becomes midnight, the temperature cools down to minus 140 degrees Celsius. And the floors of permanently cratered craters, they might get even more colder. For example, the Hermite crater near the lunar North Pole, it is one of the coldest places in the whole solar system. And the minimum temperature on the lunar surface is minus 247 degrees Celsius. And the maximum temperature is 120 degrees Celsius. Now let us take a look at the lunar craters. Now, how the moon's craters were formed was not fully understood until the 1960s, when the first robot lunar landers discovered that all sizes of craters existed, including the tiny ones. This discovery shows us that the craters were formed from impacts from space rather than volcanic eruption on the lunar surface. Now, it is clear now the moon is covered in craters, although in some places there are very old craters, and these old craters, they get covered by latest events. For example, there's one old crater over here, and a volcanic eruption causes over there. So this old crater gets covered by this volcanic eruption that has caused very lately. And sometimes other impacts will be caused on this old crater, and this old crater gets covered by this latest impact. Alright, so the moon is not the only heavenly body with so many craters, but it is a celestial body that we can learn in greatest details. Now let us take a look at the lunar surface. Now, the moon's surface, it's broadly divided into two. One is highland cratered plains. The other one is lunar seas mareas, or they're flat dark plains. Now, these highland cratered plains, they show us the original ancient crust of the moon when the satellite's crust, it solidified from a molten magma 4.5 billion years ago. Now, this crust, it's combined with silicate rocks just like the Earth's crust. And the mareas or lunar seas, they're flat dark plains. And studies show that these mareas or these dark plains, they are the plains in which old craters got erased and it became flat again. So studies show us this. They're known as mareas or lunar seas. So the moon's phases, we know the moon's phases, crescent moon, gibbous moon, half moon, new moon. These phases, since the Stone Age itself, it was useful for the farmers in the Stone Age itself. Alright, like it was used like a time, like when to sow or when to harvest these crops. And when it was Babylonian age, the astronomers not only understood the phases of the moon, they could also predict lunar eclipses. Right? These lunar eclipses, they're eclipses in which the sun, the moon, and the earth forms in the same line, and the earth's shadow is casted on the moon. Right? That's the lunar eclipse. And when it was Greek age, the astronomers understood that the moon was spherical in shape and caused tides. But the giant leap in understanding the moon was in the late 20th century, when the moon became the first alien world that people have stepped foot on. Now let us take a look at the moon's structure. So guys, this is the moon's structure. The innermost layer is the inner core, and this is a ball of pure iron squeezed solid by the pressure of the rocks around it. Then surrounding the inner core, we have the outer core, and this is the molten layer that consists of liquid iron with small amounts of sulfur and nickel. Then surrounding the outer core, we have the inner mantle, and this inner mantle is also known as partial melt. That's because the lunar mantle is partially molten close to the moon's core. Then we have the outer mantle. The majority of the silica-rich lunar mantle is solid rock, and it contains a higher proportion of iron than Earth's own mantle. Then we have the crust, and it is believed that the lunar crust probably originated as an ocean of molten magma made of granite like silicate rock. And the crust is about 48 kilometers thick on the near side and 74 kilometers thick on the far side. And this near side and far side, it is like the near side has more dark basaltic rocks and there are high melting points. And the far side, they have a brighter rocks and there are low melting points.